Okay, here we go.
So the first thing I did was I tried 2 here, and when you try to balance it out, you end up with not enough O2s. I'm not going to do it out because it takes a while. Then I tried 3, and then you do it out and it doesn't work. But then if you do 4, 4 times 3, that's going to be 12 here, CO2Cs.
Would there be 9 zeros in the first one?
Yes. So
nitrate broke up, didn't it?
Yeah.
Yes. So
Now
I
you gotta do
also
each element.
I rewrote nitrate under it as N309, and then each of those are multiplied just so I can see it easier.
That's what I was wondering.
And then you know the N2 is going to be 12 as well, so 6 times 2 is 12. The hydrogen is going to be 20, so 10 here. And then you just add up all of the O's, and then you figure out how many you need here. So you have 9 times 4, that's 36 in total. There are 24 here and 10 here, which means there needs to be 102, so I'm just going to leave that there.
Wow, what do you think? Now, and could this be reduced?
Oh, this is.
Could this be reduced?
No, because there's only one.
One of those has that one coefficient, doesn't it?
Yeah.
All right, Mason, go ahead.
Wait, how did you know to start with 4?
Because I tried 2 and 3.
You tried 2 and 3.
So I tried 2 and then realized that 3 wasn't going to work because it was an odd number and you were going to need an even number of oxygens.
Okay.
So then I just skipped 3 and went to 4, and then it
Well,
worked.
we have to know how to like. So.
Well, so this one, I don't have any real tricks for you there. It's just, you have to be patient enough and try different things. But, you know, I would say the majority of the ones you have to balance are seeded those tricks that we talked about yesterday. So that's just one of those that just, you know, you got a little trial and error. So thank you for staying with that.
Well, also it's a decomposition.
Well, we have to know
Right.
how to do the decomposition part. Like, would you give us like the left side?
Okay, great
and,
question.
like,
Certainly, I would, there's no way, if someone asked me, what does that decompose into?
Yeah, that's what.
There's no way that I would know.
Okay.
Somebody would have had to study that and be able to detect, hey, there's oxygen giving off, hey, there's nitrogen giving off. I would not have known that one at all.
Okay, so nothing like that.
No, So,
That's good.
now what I want to do now, and I'd like to spend only about 15 minutes on this. These are your favorites. There's no way, I understand in the 10th grade that I did want you to be good at this, but there's no way that I want a second year chemistry student not being really good at this. And so what I'll do is I'll help you with the first one. And then what I'll do is, let me see how many people we have. We have 1, 2, 3, 4, 5, 6, 7, 8, 8. Oh, we only have 8, so maybe I won't help you the first one. But the reason I like these is that it makes you think about a lot of things. It says, do I remember diatomic elements? Do I remember how to write formulas? Do I remember what happens in double replacement or that? How about, unfortunately, there's no combustion on here. All right, so let's see, who wants to be first? Owen, you want to be first?
Sure.
You want to pick anyone up here, come up here, and I don't care if you make mistakes, you get it? I'm okay if you make mistakes. So everybody bring your own pencil so you don't have to share pencils. McKinley, go up there so you're ready right away. You're going to be ready right away, and you can pick anyone you want. All right, what are you going to do?
All right, which one should I pick, guys?
Yes.
Now, what I want you to do, when I want you to teach us, say, and I don't care if you say, you know what, I'm not sure about this. That's fine.
Okay. All right. I'll start with number 4,
Okay,
right in the center.
Let's do it.
So potassium chlorate. So that's gonna be, first of all, chlorate is a polyatomic ion.
Excellent.
So it's ClO3 and it's -1.
Yeah.
Potassium is K, and I believe it is. Yeah, it is always +1.
Okay.
So that's 1. And then when heated yields, so yields through heat, so we can write heat.
Okay.
Potassium chloride plus oxygen gas, so CK plus O2 since it's diatomic, but that's not balanced because we have one extra oxygen. So,
Odd even trap, isn't it?
oh, yeah. Just making it neater. So if it's an odd even trap, you double the first one.
Well, not double. What's the smallest number that 3 and 2 go into?
6.
That's why you put a 2 there. So it's not really doubling, because what if it had been a 3 and a 5?
Yeah, double 3 is not 6.
Okay, there you go.
Good job, Owen.
Now, wait a minute. Now, classify. Classify.
Oh, it's single replacement.
Try it again.
It's no.
Yeah.
Decomposition?
No.
Yeah. When you
I
only
guess
have one-
decom-
When you only have one reactant, it's kind of a giveaway, it's gonna be decomposition.
Okay. Even though that it's combining here? Okay.
Did you write S?
They were already reported.
So anyway, this one is decomposition. All right, here we go.
Got him. No, I don't think I will.
He's on deck
Now, hey, you know what happened? So he learned a little bit of thing. He knew most of it, and he just had a tiny. So that's what I want. I want just talking. Let's talk it out. Talk it out. I don't care if you make a mistake. We're gonna
No,
help you a little bit.
Okay, I'm gonna do number 1,
Okay.
and I'll definitely be talking it out a little bit.
Okay.
Okay. Well,
Oh, can you sit down?
I'm sorry. I have a question. If you have a decomposition reaction with 2 polyatomic ions, do you have to show that they're
Two
not?
polyatomic.
Yeah, so like ammonium and
Phosphate, like ammonium
yeah,
phosphate?
ammonium phosphate.
Wow.
When they
Wow.
decompose, do you have to show that they're both charged at the end?
If you have decomposition, the polyatomics many times break down into something simpler. And they're, I have to look up what they're decomposed into. All right, wait, I'm ready. One.
okay. First, it's gonna be single replacement.
You're going with the easy one, I see.
Yeah.
That's all one.
And then we have zinc, so that's ZN, and it's not an gen or what's the other one? No, INE. So it can be by
Now,
itself.
here's a small point here. Should she put a little +2 over there or not?
No.
When is zinc +2?
Always.
That's not a
In a compound. Only in a compound. What is zinc when it's not in a compound?
It's a balanced element.
0. Okay, all right, go ahead.
Okay,
Don't mess up.
so I'm not gonna do that. And then, right? And then lead is not an always metal, of course.
That's why it says 2
2.
right there.
So shush, Parker.
So what charge?
So it's gonna be a +2 charge.
Okay, write that.
Oh my
Hey,
gosh.
can I, let's listen
And
to
then
the thing.
this is nitrate is NO3, which is -2, right? Is nitrate?
Nitrate's -1.
Oh, it's -1. Just kidding. So then we're gonna have 2 of them. And this yields zinc nitrate, and zinc can be +1. No, zinc is +2 always. So nitrate needs 2. Right? Is this right? Is that right? Okay.
Okay, go ahead. Go ahead.
And then lead,
Uh-huh.
which is PV.
All right, and you wanna balance it?
Yeah, it is already balanced.
Okay, so right, you have to write the word balance. Now, it just happened to be a coincidence that the lead was +2 and the zinc was +2. It's not as simple as just trading places. You get that? Everybody get that?
Yeah.
Okay, all right, thank you. Next. All right, Tim.
Can I go after Jeffrey?
No.
Can I go after Jeffrey?
Wow. The most important thing we can do right now is listen to see what they say and say, is that what I would have said?
That's what I would have said.
Which one, Jeff?
Don't choose a hard one. Do 3.
Do 3.
Do 3.
I'll do. You want me to do 3?
Yeah.
If we can all do it together, I'll
No.
do 3. So,
Hey, wait, you started,
Okay.
and we'll help you.
Yeah.
okay. So number 3. Let's do this. So sodium phosphate is going to be. That's 4, correct? So sodium is +1. Yes, is +1.
Sodium is,
Yes, is +1.
okay, what about phosphate?
Uh,
And I'll give you a clue, the only one you ever had to learn that was
it's -3. It's
is
-3.
phosphate
Yeah,
and phosphide.
yeah, it's -3. So
So phosphate's -3.
yes.
Okay,
So not there. All right, plus
There you go.
calcium chloride.
See,
Chloride.
I'm glad you went up there. Look at
Yes.
calcium. Look at the periodic table for calcium.
And then is that
Take a
already?
look at the periodic table if you forgot,
Chloride is just chlorine, but
right?
Yeah. Okay. It's already balanced, right?
no.
No.
Uh,
No?
So what column, wait a minute, what column is calcium
Is
in?
it?
That's -3.
Wait a minute.
Oh, it's -3.
What
Shoot.
column is calcium in?
It's in the
Cal-
+2 column.
Yeah, I
Alcohol
know. I know.
and
Calcium is
minerals.
+2.
Okay, so calcium's +2 and what's chlorine?
+3 or -3.
Look again, look where fluorine and chlorine, look, turn around, Jeff. See where it says fluorine, chlorine, bromine, all those, all the halogens are -1.
Oh, I'm sorry,
So
Joe.
-1 there.
I thought it was.
Alright, wait, stop,
-2.
stop,
So we were.
stop.
Okay. So it's just -1. Okay. So.
Right. Now wait, now put a minus, there you go, no wait, put a -1
Are you sure
and
it's
put a
minus?
+2 there you go.
Yep.
Alright, now, you keep going.
Calcium phosphate. So that is. Oh, that's gonna be a thing. So calcium. So it's 3 and 2. So
Okay.
Alright, very good.
Okay. plus sodium chloride. So that is already balanced, correct?
Okay, now, even though I don't use the word balance when I write
Well, that
formulas, I
one's-
just say they add up to 0, right?
They add up to 0.
Okay, now you can balance the equation,
Okay.
balance the entire equation. See any tricks there? As you scan through there, anything that kind of pops out of your mind that might help you? You see the phosphate, you see the polyatomic ion? The
Yeah, so I'll have to
If the
double.
phosphates stay as phosphate, treat them as a single atom.
Yeah.
So how many
Yeah.
phosphates are on the right? There you go.
It's 2, so I need
There you
to.
go.
So that's 6. And
There
then
you go.
so I'll do that. And then.
Very good. Now, classify.
That is double replacement, right?
Very good. Just put DR then. Okay. All right. Who wants to go next?
I do.
All right, Mitch.
I'll go after him.
Didn't you already?
Hey,
do
can
it?
I, even though some of you, listen up, some of you may think you know more than you do, if you just listen carefully to people and say, yeah, oh, that's what I would have said, that's my mistake. I'm just trying to listen to people. What do you think you're gonna do, Mason?
I think I'm gonna do number 5.
Oh, boo.
Never mind, that says acid. I'm gonna do number 2.
Which one you gonna do?
Number 2.
Okay, good.
Dang it, I don't want to do the acid ones.
So you got aluminum bromide, which that is no polyatomic ions. So it's just bromide is Br.
Uh-huh.
And aluminum is an always metal. It's +3.
Very good.
Actually, never mind.
Bromide is -1, so you're gonna need 3 of those. Plus chlorine, so that's just CO.
Yeah.
Is that is that one diatomic? Hold on.
Help me
It's
out.
in the first. Yes, it is.
Wait, how you know it's, wait.
Yeah, what are the diatomic elements?
I feel sick.
That column and that column and hydrogen over there.
Which I think, wait.
Except like the ones
I
below the little
agree,
stair.
All the ones that end in "ene," that is that column.
And then
But the other ones are the end in what?
Gens.
Gen.
Gens. So ain't
Which
that
one's in gen?
Oxygen.
hydrogen,
Uh,
heligen,
nitrogen. and hydrogen and a couple others.
Yeah, go ahead.
And that yields Al chloride, Cl. And so that one's +3, that one's -1, so you need 3 there, plus bromine. And then you got 3 bromines over here, so you're gonna need 3 over here.
Wait.
Oh, whoa, whoa.
No, slow down, slow down. Wait a minute. Now, one thing, before you try to balance it, you gotta make sure all your formulas are correct, so you got one more thing to do. You told me about chlorine being diatomic, what happened about bromine?
I would,
It's me.
Oh, shoot.
it's diatomic, guy.
Dude,
Now
I
you
got
can
you on
balance
that
it.
one.
Now you can
Oh
balance
no,
it.
it's an odd even track.
Now, what kind of trick do you see there?
I think there's an odd even trap.
Okay,
Is
good.
nitrogen, so is nitrogen
How did you
also
put the
diatomic?
nitrogen in, right?
So you got-
Nitrogen-
So, yeah, I was just wondering. Okay.
So you got 3 bromines and 2 bromines, so you're gonna need a 2 over here and a 3 over here, but now you got 2 aluminums and only 1 over here, so you're gonna need a 2 there. And that means you're gonna need a 3 here because you got 6 chlorines right here, 2 times 3, so you need 3 times 2 over there. And if I had to say that is a single replacement.
Oh
Very
my
nice.
God.
In this case-
Mason weird.
In this case, Mason, in this case, instead of the metal top taking out a metal, you have a non-metal taking out a non-metal.
Yeah, I was just thinking that.
All right, next. Somebody else.
Oh, Mason.
Oh, you get you're smart.
I think everybody
Don't
has
touch me.
everybody so far
Yeah,
has,
that's just-
has at least learned a little bit, a little bit more. All right, let's go.
So, this is single replacement. I'm doing number 5.
Let's wait till we get it done, then we.
Oh, I didn't know that. Al, and that is it's not a diatomic.
Yes, sir.
Hydrochloric acid is HCl, and I think that's also not
Not what?
diatomic.
Well, it's a I mean,
Oh,
I agree,
it's a-
but wait, diatomic means two of the same
Oh,
kind of atoms.
chloric.
So it's a compound.
It is a compound, but
Diatomic
it's
means for the same kind of.
yeah, it's just a single one.
It's the same element.
Yeah. What? So, but it's still fine because it's not. Yeah. Then it goes to aluminum chloride. So AlCl plus hydrogen gas, but hydrogen is a diatomic. So now it's that. But then that, since it's 2 over there.
Wait.
Oh.
Alcohol? Look at alcohol.
Now,
So-
wait a minute.
So aluminum is plus 3.
Parker, it's 3.
And chlorine is chlorine can be. Oh wait, no, it's +1. So
Chlorine's -1.
I meant -1, and so this must be 3.
No shot.
And then so since that's a 3 and that's a 2, I'll make this 6.
Ah,
Yeah.
And so change that to equal 6. So that will have to be 3. Since chlorine will be 6 and that's a 3, that'll have to be a 2. And since aluminum's 2 on that side, then this will have to be 2.
can you reduce it?
What is it?
No, because 3 is odd. And now it's a single replacement.
So in this case, aluminum is able to knock the hydrogen out, right?
Yeah.
Okay. Very good. Next. Marie.
Very good, Parker. Very good.
Hey, I like how you guys are sort of helping each other. It's important not to be critical. We're just going to help each other. But also, here's my opinion. I think we should be a little more confident in some of the stuff we're doing. Like, how many times have we looked up chlorine and fluorine? Don't you think by now everybody should know those are -1s? I think.
Double check.
Huh?
Yes, safety.
So I'm saying, I think we should have a little more.
Measure
more
twice, cut
confidence.
once.
I go ahead, Murray. Which one you would do?
I'll do 6.
Okay.
Okay, so calcium, and then hydroxide, and then calcium is -2, so you need
Plus
two.
two.
Or +2, so you need 2 hydroxides. And then phosphoric acid, so I'm gonna have an H. And then phosphate is, here, 4, and then phosphate is -3,
Uh-huh.
so you're gonna need 3 hydrogens.
Very good.
And then that yields calcium, phosphate, and then, so that's gonna be an odd even, or, yeah, so calcium is +2 and phosphate is -3, so you're gonna have to do 3 calciums and 2 phosphates.
Very good.
And then you're gonna have water. And then, so,
Now, even though you can balance this the way it is, sometimes, many times, if you see a hydroxide on one side and water on the other, yeah, good, very good. That'll help you balance it, I think.
okay, so, I guess you see you have 2 hydroxides, so I'm gonna go ahead and do 2
good.
there. And then, looking
Put a
at,
2 in front of your HOH also.
okay,
How many hydrogens you have that are not in hydroxide?
2,
But you have 3 on the other side.
yeah.
That's gonna cause an odd even mismatch, isn't it?
Okay, so I have to do 2 over here and 3 over here.
So how many hydrogens on the left are not in hydroxide? On the left? 6.
6.
So you need a 6 in front of your water.
Okay,
That'll give you 6 hydrogens not in hydroxide, but how many hydroxides will that give you?
6.
6. So how are we gonna make 6 hydroxides?
Then you do 3, and then you
Very
have
good.
3 calciums and
Nice.
2 phosphates.
Nice.
So,
Now, another thing, I'll give you a little clue. I happen to know, I've done this many, many times, but I noticed that the polyatomic ions, you start with hydroxide, how do you know? What if you started with phosphate, you would have automatically done what?
2 in front
You would have
of,
put the 2 in front of the phosphoric acid, and then it wouldn't have taken as long, but you know what, it still worked. It still worked, got that?
Mhm.
All right, who's next? Got 2 more to go. I'm gonna go and then you go, okay, so. Are we learning anything doing this or not?
Yeah.
To me, if you're a
Very
second-year student,
good.
if you have trouble with this, you gotta tell yourself, I gotta get better at this. I should be pretty good at this.
All
You
right.
have to push it up a little bit in the camera, or
Yeah.
pull the camera down. Okay?
All right, I'll do 7, I
Okay.
guess. So start out with copper, so that's Cu, plus sulfuric acid, which is HSO4, but this is -2, right?
Uh-huh.
And then that's got to be +2, so put a 2 there.
Because each hydrogen's +1, isn't it?
Right, so that yields copper 2 sulfate. So of Cu, SO4, and then copper 2, so that balances out.
So copper 2 is +2.
Right, and
Sulfate's
sulfate's -2. So plus water, H2O, and then also sulfur
Hang on,
dioxide.
but now, notice that this one, we have a small problem here, because what happened to sulfate?
It got split.
Sometimes when it breaks down, it's easy, sometimes it's not, so you wanna go try to balance it?
Yeah, so
Have to get.
start.
Okay, yeah, if you're in picture.
All right, so where do we need to go? So I guess we got,
I think we're gonna have to do,
Except-
instead of sulfates, have to do sulfur, right?
yeah. So we have 2 sulfurs over here. So we put 2 there.
Okay,
Then we have 4 hydrogens. So try 4 there.
that'll make 8 though. Smile pretty.
Oh yeah, that's my bad. Put a 2 there.
Okay. Well, now, if the oxygens, what do you think about oxygens on the left? How many oxygens on the left?
We got 8
on the
oxygens
right
on the
now?
left. And then we have 8.
Ooh.
So yeah,
In this case,
that looks
it
pretty
wasn't
good.
so bad, it wasn't so
Yeah.
bad.
And I don't know, is this
Well, this one's interesting because it doesn't quite fit the model, but copper kicked out somebody, didn't it?
Yes.
So copper, even though copper should have kicked out hydrogen, it ends up kicking out hydrogen, and it looks like it's combining with oxygen. So, wow, that's a weird situation here. I don't know if I'd ask you to classify this one. I mean, if it is single replacement, it produces weird things, doesn't it?
Yeah.
Okay, all right, next. Oh, the one on number 6, Marie, what was our classification on that?
Oh my gosh.
Single replacement, okay, good. Now you can, on the camera, you might have to pull the camera on top of the paper.
Okay.
Just kind of lift it up and put it on the paper. Okay, I can do that. All right.
Okay, so first it's hydrogen, which is a gen, so it has to be 2 diatomic, plus N monoxide, so 1, and nitrogen is minus. Oh wait, no, that's it. And then yields H2O and N2. And since there's 2 nitrogens, there's 2 here. There's 1 oxygen, but there's 2 on this side, so there's 2. There's 2. And
What do you think?
4 hydrogens, 2 nitrogens, 2.
And this one also, I don't think quite fits some of our models. And by the way, the 5 classifications, this doesn't mean that's the only kinds of classifications there are.
Is that-
This is the 5 most likely ones. So I don't know, it's a hard question. Who do you think hydrogen kicked out? Kicked out the nitrogen, right? So it's possible that you could call it a single replacement by kicking out the nitrogen. So I think so. Kind of weird though. All right, what do you think? Anybody feel a little bit better about these? Yeah. So you can see where, if you look back, you said, well, no wonder he has to learn the elements. No wonder he has learned the polyatomic ions. And I won't be able to do these. I won't be able to do these if I don't know these. Okay. All right, today, the second thing I'd like to do, and when you get back next, I won't see you till like Tuesday, right? When you get back on Tuesday, we'll get into a little bit more mathematics. We'll get into a little bit of mathematics today. So this chapter, the same author that wrote your 10th grade book actually writes this book. And one of them is called Zoomdahl, and this is called Zoomdahl and Zoomdahl. So I don't know if it's his wife or whoever it is, but anyway, that's who wrote the book. But if you remember in the 10th grade, they talked about jelly beans. And I'm going to go over that one more time because you're older and you're smarter. So let's try it again. How in the world do scientists know how compounds react with other compounds? How do they know how many atoms of this react with how many atoms of that? How do they know that? And number one, no one's ever seen that. No one's ever seen a chemical reaction take place at that level, at the atomic level. I've never really seen it. So how in the world did we figure out that that was what's going on? Well, first of all, the first problem was, in the world of chemistry, I have to know how many pieces are reacting with how many pieces. So take a look at this. Imagine this reaction without the coefficients. I'll write it up here. Hydrogen will react with oxygen to form water. And all we need is like maybe a spark or something like that. It's a very violent explosion. Now, if you look at this right here, let's say that they knew, they identified a gas as hydrogen, they identified them as oxygen, they put them together, a big explosion, they got water, and they said, well, you know what, water is, hydrogen and oxygen makes water. But see, the problem is, we eventually had to figure out that there were diatomic elements. We didn't know that one time. And then the next thing is, this wouldn't make sense. If I were to draw this, if I were to draw one of these, okay, up here. Wait a minute. Mason, can I have this for you? So if I were to draw this, that wouldn't even make sense. It wouldn't even make sense because if I took this and this, could I make one of these? He said, well, that wouldn't make sense because I can see those two being there and one of those, but wouldn't you have something left over? And so the whole thing didn't make sense until they figured out I can actually count these, and then that's when you balance equations. So we balance equations to make sense in the world of how many atoms are reacting with how many atoms. And that makes sense. If I draw two of those, two of these, and one of those, then you could rearrange those and form two waters. And that's what balancing is all about. So they knew a long time ago that knowing how many particles in the little world is important, but first of all, they're too small, and there's too many. You can't count even 1 million. I mean, how long does it take to count 1 million if you count one a second? You know, you're talking about a very, very long time. You can't do it. So scientists had to have an indirect way of measuring how many, counting atoms. And here's the jelly bean analogy one more time. If I did have a store and I had jelly beans, and people came in, they liked the jelly beans, and they say, hey, can I have 5 jelly beans? No problem. I take my employee, counts out 5, charge them for them. Next person in line, next person in line. But what would happen if somebody says, I need 1,000. I need 1,000 jelly beans. Well, first of all, you'd be paying this person like $10 or $12 an hour to count out 1,000 jelly beans. And you'd be losing a lot of money, wouldn't you? So you have to figure out how to do it. So if I owned the store, what I would do is I wouldn't count just 10 jelly beans at random. I would weigh maybe 1,000. Weigh 1,000 individual jelly beans. And some of the jelly beans, 5.1, 5.2, 5.0, 4.8. Everybody see that? Now this is analogous to isotopes. If I counted hydrogens, a lot of them would have a mass of 1. But then I'd have one that had a mass of 2, wouldn't it? And another one with a mass of 3. And so that's what this analogy is about. So what would happen is, if I added up the masses of all 1,000, and then I divided by 1,000, I would get the average mass of a jelly bean. Now, I hate that the author, I wouldn't have done this as an author. If I was an author, I wouldn't have had the average come out to be 5. I would have said like 5.01. That would have made the point better, I think. Because if I tell you the average is 5, you say, oh yeah, there is a jelly bean. But what if the average came out to be 5.01? How many jelly beans had a mass of 5.01? None of them. And look up there. That number you see up on the periodic table, how many sodium atoms have a mass of 22.98?
0.
None. Everybody get that? None of them. But if you give me a whole bunch of sodiums, then the average is going to be that. Same thing here. So if I know the average mass is that, and everybody wants 1,000 jelly beans, watch, 5.01 times, I count out 5,010 grams of jelly beans. I put it in a bag, say thank you very much. And that wouldn't take very long. I could weigh the jelly beans and divide by this number, and I would know how many jelly beans I had. And so we're counting by not counting. We're counting by doing what? We're counting by not counting. We're counting by weighing. And that was a big breakthrough in the world of chemistry. And the last thing I'm going to show you here, I only have a couple minutes. I showed you this on the last chapter. What a machine. I talked to Miss Founds and Michael, who was at Virginia Tech, UVA, sorry. And they actually are paying for him to get his master's and doctorate in chemistry. And one thing he's really enjoying is they do have 2 mass spectrometers. Now, a mass spectrometer is something that you put in there, and they can analyze what you put in there. A lot of police departments have it. Greensboro themselves may not have one, but they'll send it to Charlotte or Raleigh. And they would have a very big forensics department. And what they would do is they probably would have a mass spectrometer. Now, I know you don't believe this, but if they took some cocaine and put it in a mass spectrometer, it would tell you every type of atom or every type of molecule in there. What if the material they used to make the cocaine, what if the glassware had an impurity in it? It would point that out. And then every time they saw that kind of cocaine with that exact fingerprint, they would know that probably from the same producer. They do the same thing with glass. If you break into a building and you have glass in your shoes, and you don't think there's any glass in your shoes, but it's in there, if that glass was specially made for that building, they could put you at the scene of the crime by knowing that that glass was only made for that building. So anyway, mass spectrometer is pretty neat. Now, I want to show you real quickly, then I'll stop here. First of all, when you're talking about the mass of atoms, what you had to do, and I've talked about this in physics too, you have to have a standard. Now, does anybody know what the standard is? They decided to say, we gotta have to have a standard mass, and if you're twice that mass, then you'll be twice the standard.
My guess is 12.
I would have guessed hydrogen, but they didn't, because hydrogen only has a mass of maybe 1, right? Most of the time. And I think they were afraid of error. I thought, if it's only 1 and you're a little off, so they did pick carbon. You're correct.
Yes.
Now they picked which isotope of carbon? The standard of all these numbers are based on carbon 12. Now that means you have 6 protons and 6 neutrons. Got it?
Totally get it.
Now, watch right here, and then this last thing we'll do. You look up here though, and notice that it doesn't say 12. It doesn't say 12 on the periodic table. But each carbon 12 has a mass, I hereby declare, is 12.00000 standard. But if you give me a lot of carbons, not all of them are carbon 12. You get that? So for example, carbon 13, look at that. How much more did it weigh? How many times heavier was carbon 13 than carbon 12? That number. Anyway, so you look through here, and I guess I'll just leave it there, but what they do is they do a weighted average, and so if I give you a lump of carbon to do an experiment with, is it all carbon 12? No, that would cost a lot of money. All right, you have a nice break. Have a nice break, okay?
You too. Any big plans?
What now?
Any big plans for fall break?
Well, my grandkids have like 3 soccer games, so I'll be here. I don't know. Are you going anywhere?
Not yet.
This year, so far, I'm not going anywhere, but maybe I might. Rollins, how was your leadership thing yesterday?
It was good. It was like the orientation, so we didn't actually do what we usually do, but we have it the first Wednesday of every
So these are people from all over different schools and stuff like that? Okay.
Well, that sounds good to meet. I mean, are you meeting good people? You know what I mean? I know it's extra time, but
It's good.
it's
I know.
time well spent to meet good people. I think.
Yeah.
It's a lot of kids who are
Right. Wow, man, you've been working.
they're very,
All right.
very, very smart.
And then, so you were talking about
Like you,
maybe
that
taking
you
the
fit in
polyatomic
very,
ion
very
on
well.
Tuesday?
Yeah, I can take that Tuesday.
Okay.
And then I didn't realize this, but we have a camping trip
Okay, okay.
Wednesday, so
You can check next day or not?
Okay.
If you had any
I
time,
meant what I
if you
said.
want to go over
You
before
fit
you
right
take
in
the
there.
test, you say, I want to go over some stuff. Just give me the time.
okay. So we're not here Wednesday or Thursday.
Oh, why not
Good.
Thursday?
We're at the camping trip, so it's an overnight thing.
Wait, the camping trip is now overnight? What?
Yeah.
So you're not here Monday,
14.
and you're not here Wednesday or Thursday? Oh,
Yeah,
did you
so
hear that?
I could-
I did not know that.
I'm not sure if I'd be able to come
Okay.
in the afternoon
No.
on Thursday.
Well, you could. I'll be here, but
or
I think you definitely should take the test before the end of the week.
yeah.
But
So I can definitely for sure take it during lunch on Friday and during after
okay,
school on Friday.
okay,
if
we do that.
So okay, thank you.
All right. I did not know. First of all, it's kind of like secret. Like that the seniors might not be here.
Okay.
Now it's into a full-fledged.
Okay, can I tell you, Clayton, I'm gonna embarrass you. That is why I super love Clayton Dunn.
Oh, of course. You kidding me?
He came, I super love you, man. He came up here and just I knew there was some secret whisper, because I was going for a test, and all of my seniors talking about a test were like, you can't pick that day.
Yeah.
And I said, why? And they were like,
Well, now they actually have a poster out there.
we'll tell you later.
They
And
actually
I
have
was
a
like,
poster advertising the campus.
oh, okay, see, this was earlier in the week, so I was like,
Generally.
you can't tell, oh, see, look, and so I was like, look at Clayton, he's just divulging a secret for the good of a test.
Yeah, I mean.
Well,
Just take the
he just-
praise, man, just take it. All right, I am taking off, so there's his test for lunch,
Okay,
so thank you.
sure. It's easy. Real easy.
See you later.
Thank you so much.
You're welcome so much.
For this morning.
So,
I wanted
I'm
to catch
actually-
you before you left.
You're welcome so much, that was good.
All right, well,
See you later.
make the best of it, and, sorry.
It is what it is.
Okay. Oh.